I'm Victor Hayashi from Polytechnic School, University of São Paulo, Brazil. I'm gonna talk about OKIoT Open Knowledge IoT project, smart home case studies of short-term course, and software residency capstone project. So opportunities are arising on smart home, connected car, and smart city domains. For example, Canal is estimated 200 million smart speaker devices by 2019. And along with these opportunities, challenges are arising for developers. Questions like considering trade-offs between simple devices and robust computational platforms such as cloud. How can one deal with faults like internet unavailability that we have here in Brazil, for example? And if I have a background on software development, how can I overcome this hardware initial learning curve in order to develop IoT solutions? This motivated us to build an accelerator for the smart environments based on three concepts. The first is the modeling, so developers could understand software engineering fundamentals, the technology's usage, and the constituent parts, and as well as the integration, the architecture that builds the solutions. The hardware accelerator encapsulates power control over smart plug appliance with rastreability components like log files and serial communication used to integrate the solution easily with your Arduino projects, as well with a fault-tolerant architecture provided with documentation. Software solutions. Projects should be hosted on platforms like GitHub together with their components, so it could be used to build and deploy easily. So future developers could understand, use, collaborate, and advance existing solutions, not just build the solutions from scratch. Have been on the smart home field since 2016 with the software engineering with IoT methods. In 2017, we had my Capstone project about a fault-tolerant smart home that it remains connected to people even when the internet is not available. In 2018, we had the smart home testbed. We built this open data smart home repository. And last year, we had this OKIoT project, the Capstone project, the short course that I'll present. So, the first drawback that we will address is the limitation of the closed architecture, specifically for the smart speaker. One of them is the preset wake word. For example, it limits the freedom of user interaction, raises problems for users whose names resemble the wake word, for example, Alex. The second one is the vendor lock-in. Backend services and natural language understanding modules are attached to vendor platform. So portability becomes a challenge as the assistants would be duplicated on different platforms and could have different responses for similar questions. In order to tackle these problems, some smart speaker projects have been proposed. One of them is the speech recognition. It's a library that makes it easy to use different speech recognition services, making it possible to choose by command line interface which speech-to-text service the developer would like to choose. Snowball is an open alternative for wake word creation. An open voice command interface kit developed a low-cost hardware for smart speakers. An Alias project created a hardware that blocks smart speakers listening with a white noise in order to provide a customized wake word and deal with privacy concerns. There are also several commercial platforms that support advanced capabilities like cloud computing, machine learning, and big data services, easy integration with voice interface, but they all share this common drawback of vendor lock-in. Some open IoT platforms have also been launched, and even some institutions create their own tools for educational purposes. But the point is that the multiplicity of languages, communication protocols, hardware boards, and interface make it a challenge to build a unified platform for IoT. And also, engaging and retaining a broad developer community is no easy task. As applicants have different system requirements, it is difficult to wonder about a platform that could be flexible enough to support all applications. How to integrate these projects in order to create a smart speaker with the open architecture also still remains an open question. So our hypothesis is built on the premise that knowledge is an intangible asset easy to share, agnostic to technology choice, and not subject to vendor lock-in. Our objective is to build an open knowledge sharing community that engages developers and enthusiasts skillful in different technologies, taking smart home as the starting field. With the focus on knowledge, the key differential is the integration of software engineering methodology with IoT education. An open architecture for smart speakers that allows developers to choose between different services on each step of the voice interaction process, namely speech-to-text, natural language understanding, and text-to-speech, with the objective to optimize its end-to-end performance. As for the method, we validate our approach by taking qualitative feedback on proposed project-oriented methods, short-term course, and Capstone projects. On September to October 2019, a short-term course on an MBA course offering was supported. An accelerator kit and its manual were given to each of 5 groups. One training session of 4 hours was implemented on each of the 6 weeks. As the opening class was based only on introduction and the last year had the final presentations, it means that 4 hands-on experiments were performed on the remaining weeks. For the project-oriented methodology, we presented the major interest areas of the smart home in order to motivate these 5 groups. We used this demonstration case to showcase how the smart home project is being developed. And we provide each of these groups with this IoT kit that have components of a real-time clock, two-way switch, the lamp, and some Arduino components. It is all based on a fault-tolerant IoT architecture. So the 4 hands-on labs that we had were the 0 step was based on physical switch to the module. The step 1 was based on this infrastructure being a Wi-Fi access point and a smartphone connecting directly to it and accessing it and monitoring and commanding. The second one was on the Wi-Fi network, so the smartphone could access not just one, but lots of devices on the same network. And the third one was the cloud integration. It was also provided with videos, so they could take this kit home and try themselves as well. For example, in this video, we have this app based on the cloud, where you could monitor it and command your device. Also monitor it when someone turns it off, for example. And for the local interface, we had also this web page that is based on the model itself, where you could control and monitor it. So this interface showcases the free level fault-tolerant solution that I showcased to you. A software residency program was also deployed over February to December of last year. It was composed of some steps: user-centered value proposition, software engineering modeling methods, then iteration with the agile methods, and then results analysis, documentation of the results and analysis. For OKIoT, this is the most important step as it is how the knowledge will be passed on. This is the API that we have built for the smart speaker basic services. So each of these basic steps, we had two alternatives, commercial alternatives for each one. So you could evaluate if an open architecture could help us or not. So 4 different audios were analyzed for a total of 200 tests. The audios were chosen in order to consider the clarity of speech and the noise of the environment. First audio, the speech is loud and clear without external interference. The second recording contains a song that's played along with the speech. The third one has a certain echo and an ambient noise. And the fourth recording, we can understand the speech, but some effort is necessary due to the low volume of the speech and the high environment noise. Some findings that we had in this short-term course is that more classes must be integrated, projects could be more related to everyday life, smart home area generated interest or some students to continue with personal projects. Hands-on approach was approved by most students, and we must explain some practical cases concerning the software engineering methodology in a more dynamic way. Smart speaker results provide an initial proposition that combining different vendors' basic services could be the best option for an efficient smart speaker with minimized response time. On the first and the although we had no significant difference between IBM and Google, for example, but then with the second one, Google could have a better transcription. The third audio, Google could understand some words, but IBM not, and the fourth audio as well. This was for the qualitative part. For the quantitative part, we had the response time, the average response time on each of these steps. And it showed us that if you close the smart speaker architecture, if the audio number 1, we have more than 30 seconds of response time. And with an open smart speaker architecture, you could have less than 20 seconds. We have used this API and built a Raspberry powered smart speaker, open smart speaker, that is this one that we have built with a 3D printer, along with another IoT module for elderly care. For the conclusion, OKIoT project initial results were presented. Proposed IoT education method, project-oriented with software engineering methodology, was evaluated on short-term course and long-term Capstone project. A study on open architecture for smart speakers and associated evaluation methods were also presented as one initial contribution to OKIoT. As future steps, OKIoT roadmap includes more support to developers, online course, support to undergraduate course, and a hackathon. And additionally, problem-based learning. And I have to share with you that as for the online and undergraduate course, we have been using this year in order to deal with the coronavirus outbreak. We have been using IoT to provide hands-on experiences remotely using all this Internet of Things architecture that I showcased you. So these steps are also being followed. This is our GitHub. So if you want to see how we deployed the solutions, the documentation, the results, feel free to reach to us. And thank you very much for your time.